Welcome back. In this tutorial, we're going to learn about the ellipse and its subtools, the partial ellipse, the parabola, and the conic curve. So first order of business is to create a sketch. Let's do it on the top plane. Now let's activate the ellipse tool. Our first click determines the center of the ellipse. The second click the major axis, that's the long axis, and the third click is the minor axis or the short axis of the ellipse. Now let's take a look at the partial ellipse. It's pretty similar. Once again, first click is the center, second click is the major axis, third click is the minor axis. Now we have a fourth click that determines the length of the ellipse. Okay, let's take a look at the parabola subtool. The first click establishes the focus of the parabola, the second click the vertex, and lastly, the third click for our parabola determines its length. The last subtool is the conic curve. The conic curve subtool was actually first introduced in SOLIDWORKS 2013, and it does warrant a bit of a deeper explanation, so let's talk about that. Let's begin by creating a sketch. The Conic Curve tool is part of the Ellipse submenu. In previous versions of SOLIDWORKS, we had the option to create an ellipse, a partial ellipse, and a parabola. Now we've also got the Conic Curve. Creating a parabola involves 4 steps, selecting a focus, vertex, then a start and end point. This approach makes it difficult to reference existing geometry, so that's where the Conic Curve tool comes in handy. It can be difficult to snap the end of a parabola to a line, for example, if you need to create tangency. Let me try an example. I'll begin by placing a couple lines. And I'll apply a fixed relation. Let's activate the Conic Curve tool now. We're going to snap to these endpoints. Next, we'll define the focus, and finally the vertex. And as you see, we've incorporated tangency into the sketch. Let's try another example. This time I'll start with a spline. Then a 3-point arc. And let's activate the Conic Curve tool. I'll snap to the endpoint of the spline and an endpoint of the arc. Then I'll place the focus and lastly the vertex of the curve. Okay, let me create one more example. I'll just pan to the right a bit. I'll start with a couple lines first. The second line, something like this. Now let's bring in the Conic Curve tool. And we'll snap to this endpoint and this endpoint. Now let's say I snap to the intersection of both of these lines. My curve would have tangency to both lines. Let's apply some smart dimensions. Accept the default value. What I've dimensioned here is called the rho value, that's RHO. The rho value is used in math and physics and many other disciplines differently, but essentially here it has to do with the shape of the ellipse. Let's see where this value comes from. Let's create a construction line. Now activate the Conic Curve tool. Place our first point, the second point. And here is our first curve. Let's create a second curve, and curve number 3. Now let's apply some dimensions. Okay, for the default value there. Let's make this one 0.5. Okay. And the default value is fine here. As you've probably guessed now, the distance between this line and this point is 1. So basically, if the rho value is more than 0.5 but less than 1, we've got a hyperbola. If the rho value is 0.5 equal to 0.5, we have a parabola. And if the rho value is less than 0.5 but greater than 0, we've got an ellipse. Let me bring in a model. Let's say you take a cone and you slice it with a plane. This leaves us with an example of a circle, an ellipse, a parabola, and a hyperbola. And this concludes our tutorial.